Hello, geometry students. Okay, today we are learning about the surface area of a cylinder. Now, a cylinder, I think of in my head, I always say I think of a cup. It looks like a cup. But a solid cylinder would have both ends covered. So you think about that. This is not a solid cylinder. This is just the outside of a cylinder. Okay? I took my paper towel roll from yesterday and I cut it into a little cylinder. Now, what we have to do when we're trying to measure the area, well, the lateral area, remember we talked about this yesterday, the outer area. Think of it, I just want to know how big the cardboard is. So, the question is, how big is the cardboard? That's a really, really interesting thing to think about. Where is it? Where's my scissors? Hold on, I'll be right back. I gotta grab my scissors. So the question is, what is the area of the cardboard in this problem? Well, I don't know. It's how do you measure this? This is how you measure it. I'm going to take this cardboard. I'm going to look at one important thing. How long is it? This is going to be called the height from here to here. Then, watch this. Pair of scissors. Come through the cardboard. And I cut it. Now I know this length that I just cut is h, height. But what is this length? I unfold it and I get a particular shape. I get a rectangle. My rectangle has a height h. But what is this? This one here. Okay. Well, I know what that is. Look at this. What shape is this? This is a circle, right? I can determine what this shape is because there's something called a circumference, which is the area on the outside of a circle. And the way we measure circumference is 2 pi r. So, if I want to find the lateral area of a cylinder, I can think of it as a rectangle. Rectangle, the area of a rectangle equals base times height. Well, my height is here. This length. This would be h, right? So I got the height. This would be the base. And when I fold it over on itself, I realize it's just a circle. And the length of a circle going around the edges is 2 pi r. So the area is, well, we're going to call this the LA. LA is lateral area, which you remember from yesterday's lesson, means just the letter on the outside here. Not the circles, not the bases. Just the stuff on the outside. Just the cardboard in the paper towel roll. So lateral area then is base 2 pi r times h. I love it when they say leave things in terms of pi. Remember this from yesterday. When they say leave something in terms of pi, that means I don't have to worry about decimals. So I can use the cumulative property of multiplication, which means I can multiply in any order I want. So I'm going to change the order. I'm going to put pi at the end. 2r h times pi. So I'll multiply these numbers and I'll leave pi at the end because I can move 2 times 3 is 6, 3 times 2 is 6. Doesn't matter. Multiplication can go in any order. Now, this said the cylinder has a height of 9 centimeters, so this height becomes 9. A radius of 10 centimeters. I have this 2 in front. And all these numbers are going to be multiplied by pi. But I'm not going to worry about that because they want me to leave it in terms of pi. Okay, so what is 2 times 10 times 9? Well, in effort to save a little time here and not use the calculator, well, 2 times 10 is 20. 20 times 9, 180. 180 pi, because we're leaving it in terms of pi. So the lateral area is 180 pi centimeters. That's the most accurate number you get. Technically, you really can't write a number more accurate than that. Because if I do in the calculator, and I want to find out what really 180 pi is, look at this number. Wow. Second, don't look at that number. 180 times pi, I get this really ugly number, 565.4866776, and this keeps repeating on and on and on and on and on. This is more accurate. Okay? If they don't say keep pi, then this is your answer. Then all I would have done, if they said, just in terms of maybe they said the nearest inch or nearest centimeter, I would have just done this. 2 times 10 times 9 times pi. You do this on the Decimal Scientific Calculator and look at that. Same number. Very interesting. Okay. I'll be back with the independent practice. Good job.